rationalize the denominator. So in part A, we're dividing by 3 minus the square root of 5. So we're going to multiply top and bottom by its conjugate. What's its conjugate? 3 plus square root of 5, yep. Correct. Right. Because what you're doing is you're multiplying by 1. You're not changing the value of the number, you're only changing what it looks like. So in the numerator, we're multiplying 1 term by 2 terms. So what do I do with that 4 in one word? Distribute. Let's do that now. What is 4 times 3? What is 4 times the square root of 5? 4 square root of 5. Good. Downstairs, we have 2 terms times 2 terms. What do we have to do? FOIL. What would it first give me? Outer plus 3 radical 5. Inner. Good. Last. Yep. Minus times positive makes minus. Radical 5 times itself is 5. By design, what happens to the 3 radical 5s? And 9 minus 5 makes 4. 4. Now, notice, this cleans up. I would prefer you thought of this as 12 fourths plus 4 radical 5 fourths. And then reduced it. What is 12 fourths? 3. What is 4 radical 5 fourths? So your final answer is 3 plus square root of 5. What I don't want to happen is, let's suppose, I'm going to write this up here. I had 12 plus 3 radical 5 over 4. This is the most common mistake I say. Students are like, oh, look, 12 and 4. That's cool. I'm going to reduce that there. All right, so that gives me a 3, and this 3 radical 5 sticks around. Why is that wrong? In order to cancel and a fraction, the numerator and denominator must be a multiplication, must be a product. Is this a product right here? No, that's a sum. So if you break it into pieces and then reduced, that's cool. But if you did have this one and you did want to reduce it, and if you broke it into pieces first, could you do anything with the second fraction here? No, nothing reduces. So this would be the proper way to break that up and clean that up if you wanted to. But unless everything has the same multiple in the coefficient, then you can't reduce it. All right, bang. Same process. We're going to multiply top and bottom by the conjugate. What's the conjugate of the denominator? A lot of square root of 5 here. Sorry about that. 1 minus square root of 5. However, unlike part A, in part B, we have to FOIL in the numerator and denominator. So if we FOIL the numerator, what does first give us? Outside? Out. Good. In. Square root of 15. Negative times negative makes positive. Square root of 3 times square root of 5 makes square root of 15. Downstairs FOIL first. Outer. upstairs, are there any like terms? So remember, when adding or subtracting radicals, two things must be true. What are those two things? Same index and same radicand. Well, they all have the same index except for that 2. 2 doesn't even have a square root on it. But do they have the same radicand? No. So the numerator stays 2 minus 2 square root of 5 minus square root of 3 plus square root of 15. Downstairs, the square root of 5's cancel. Careful. Negative 4. Can I reduce the 4 and the 2? Is the numerator a product? Is the entire numerator a product? No. Can I reduce the 2 and the 4? No. Those were all 2's. Why aren't you working up here? I'm making this up. Oh, I forgot my 2. Oh, jeez. Oh, no, I erased too much. The way you can think about it is if those were all 2's for the coefficients, you could factor out a 2, then there would be a 1 here, square root of 5 here, square root of 3 here, positive square root of 15 here. Well, factor means to write as a product. Well, now since this is a product here, what can I do with this 2 and this 2? They can cancel. Just like over here, we could have factored a 4 out of the numerator and canceled. You would still get the same.